Hi guys, in this video we shall see another problem on LeetCode. Divide two integers. So given two integers, dividend and divisor, divide two integers without using multiplication, division and mod operator. So the given dividend and divisor. So we know if I am dividing, let's say 6 by 3, then this will be the dividend and 3 would be the divisor. So they given two integers, dividend and divisor, and we have to divide those integers but without using any multiplication, division, mod operator. So what do you mean by that? In division, we know usually dividend will be equal to quotient into divisor plus the remainder. So remainder we get by using mod operator. This is multiplication operator. So this is how you usually we do the division. But without using any of these operators, division, multiplication and mod operator, we have to perform the division here. And we have to identify what is the quotient for this dividend divided by divisor we get it for this division. So the integer division should truncate towards 0, which means we have to lose its fractional part. So 10 by 3 will be 3.33, so truncate it to 3. 7 by 3 will be 2.33. Then it will be 2. Return answer as -2. So that is what they told. And one more thing, return the quotient after dividing dividend by divisor. So assume we are dealing with an environment that could only store integers within the 32-bit signed integer range. So they are saying at, at last the result should be within the integer range. If it becomes an overflow or underflow anything, then what we need to do, we need to just return int max if it is greater than the maximum value, and int minimum if it is lesser than the minimum value. So we know int max is, so first case we need to handle is that only. So int max is nothing but 2 power 31 and int minimum 2 power 31 minus 1. So int minimum is nothing but 2 power 31 minus 2 power 31, right? So this something something ends up with 47. Here it ends up with 48. So if it is maximum and if the divisor is 1 or -1, it's okay. If divisor is 1, we will return this one. If divisor is -1, we will return 2 power 31 minus 1 in the negative format, which is in the range, integer minimum range. But if we have integer minimum and divisor is -1, then integer minimum by -1 will give you this 2 power 31. So which is greater than 2 power 31 minus 1. So that one case we need to handle. Other case we need to handle is they have given integer minimum and divisor is 1. In such case, directly return the integer minimum. So that are the two cases. So int minimum and divisor is 1. So int minimum and divisor is -1. So in this case, we have to return int minimum only. Here if it is -1, then this is out of range. So in such case, we have to return int max only. You cannot return 2 power 31. You have to return 2 power 31 minus 1 since it's greater than out of bound. Overflows occurring, return int max. So this is the case. So this is the first case which we need to handle. So after this, I'll really erase all this. And they told divisor is not -1. So not 0. Sorry, not it will not be 0. And they told dividend, either dividend or divisor, they can be either positive or negative. So before doing the division, we have to convert into positive numbers. But before converting it positive numbers, we should get to know whether it's a answer should be in the positive or negative. So how do we get to know? So we know in division or multiplication, plus plus will plus plus, minus minus will give you plus only. Plus minus or minus plus will give you minus as the answer. So we need to handle this case. So if any one of the either dividend or divisor is minus, then only the answer will be minus. If both are plus or both are minus, then the answer will be plus only. We need not to take care of that condition. So how do you get to know whether one of them is negative? So for that you can use XOR operator. XOR means if either of the answers given question has negative or alternate answers, then the answer will be negative. So what we need to do is, if we have to check divisor dividend is less than 0 or XOR with dividend, sorry, not dividend, divisor lesser than 0. So if any one of them becomes true, if any one of them becomes true, then what will happen? It will be minus 1, otherwise it will be 1. So that is what we need to look after. So this is one case, this is second thing which you need to take care of. So once you change, check the sign. So as I need to sign, okay. So after taking sign, so it will be minus 1, 1 accordingly. So if it is 10 minus 3, answer will be minus 1. If it is 10, 3, it will be 1. Or minus 10 minus 3, it will be 1 1. So my first case is this overflow case. Second case sign. Third case, now change dividend divisor to positive. So we will take the data type here long, long. In C++ it's long, long. In Java it's only long is fine. So why are we taking data type long here? See, as I said, integer maximum value we will have. So that is 2 power 31, 2 power 31 minus 1. So it will be something 222 something something, then 4 7, it ends with 4 7. So if we have the divisor as 1, then that causes a problem. What problem it causes? That we will get to know later. So for now, just imagine we will take the long as a data type, and intermediate result can cause overflow, but the end result will not cause an overflow here. So long, so we'll take long dividend and long divisor. So that will be absolute of long absolute in case of C++. In case of Java, man dot absolute you can take of dividend and divisor. So first step is this, second step is this, third step is this. This is done. Next comes to the actual main part. So that I'll explain now. So these are clear. I won't explain this again. While programming only you'll get to know. So for the next part, so how do you perform the division now? So usually if we have 6 by 3, you know this is dividend and this is divisor. So 6 by 3 will result in 2. We have to return the answer as 2, but we cannot perform this direct division here. So what else we have to do? We cannot use any multiplication mod operator also. So 6 by 3 is nothing but what? It is nothing but 3 we are adding 2 times. If it is 2, means adding 3 2 times. If it was 9 by 3, that will be 3 only. That means 3 we are adding 3 times. So that will give you 9. Here it will give you 6. So that is what answer we are written. So what we will do the reverse of it. If they have given 6 and the divisor is 3, subtract 6 minus 3. How much it will give? 3. Okay, it is still greater than 3. Then again 3 minus 3 you do. How much it is? 0. So how many times? This is 1 count, this is 2 count. So answer is 2. Similarly for 9 as well. Or let's say 10 we will take 10 by 3. Then 10 minus 3. How much will it give? 7. 7 is greater than 3. 7 minus 3 you do. 4. 4 is greater than 3. 4 minus 3 you do. So that will give you 1. 1 is not greater than 3. So 1 minus 3 is not possible. This is not possible. So this is 1 count, 2 count, 3 count. So the quotient will be 3. So this is a normal approach. But what happens is, if the number is too large, then that will be a problem. Right? Let's say if the number is some 10k and divisor is 1, then subtracting 10,000 times will be a very long process. It will be a huge time complexity will happen. So that's why it's very time consuming. So that's why you have to look for other optimal solution. So here comes the bit manipulation method. So we'll use the bits here. So how can we solve the problem? We have 10 and we have 3. So what we will do is, dividend is 10. We will double the divisor every time. So 3 2s are how much? 6. So now check whether until we get dividend greater than divisor. So 10 is greater than 6. Fine. Next again double it. For this dividend 6 2s are 12. So this time you could see dividend is not greater than divisor. So check. Next again what we have to take is subtract 10 minus 6. How much you get? 4. Take that as a dividend. Then divisor will be 3 only. Again double 3. 4 is greater than 3. Fine only. Then 4 will be dividend. Double of 3 will be 6. Is 4 greater than 6? No. So done here. Now 4 minus 3 you have to take. 4 minus 3 how much will it be? 1. And dividend divisor is 3. 1 is not greater than 3. Now here you can stop the loop. So you could see 1 time, 2 time, 3 times. 10 by 3. The answer you get. So this is how you have to solve the problem. So if you carefully see here, 3 we are multiplying by 2 times, 6 we are multiplying by 2 times, 3 multiplying 2 times. Every time 2 times multiplying. 2 times multiplying is nothing but you are doing left shift by 1. So left shift indicates multiply by 2, right shift indicates right shift by 1 position is dividing by 2. So it is 2 power n times. If it is n times, then 2 power n times, multiplying by 2 power n times. If it is right shift by n position, then dividing by 2 power n times. That is what we have. So if it is 1, multiply by 2. If it is right shift by 1, then divide by 2. So this is left shift. So here what we are performing, we have the 3, right? So here divisor, we are left shifting by 1 position each time. So we have to check until you have divisor left shift by 1, that is that should be less than the dividend. If divisor left shift by 1 is less than the dividend, then keep on doing the divisor left shift by 1 position. So 6, then 12. When it comes to 12, it will stop the loop. So here at the same time you have to calculate the quotient as well. So how do you calculate the quotient here? So quotient, let's say we will have a variable called multiple. Multiple we initialize it to 1. So multiple will also be left shift by 1 position. Why? So I take another example. We'll get a clear idea why am I telling that. Because logically we are multiplying by 2 means 2 quotient is there. Again multiplying, again 2 quotient is added. So that's why we are left shift. Sorry. So that's why we are left shifting by 1 position. That means multiplying by 2 each time. So let's take another example, proper example, 20 and 3. So you have 20, you have 3. So again, while dividend should be greater than divisor, so we'll have a variable called temp. In the temp, we will store the divisor first. Okay. So once you store inside the temp divisor, next, because original divisor you cannot change, because if we change the original divisor, divisor will be 12 here. That cannot be taken to the next count. So that's why initialize temp to divisor. So that 3 will be there for the next round as well, for this round. So at the end you have to check whether dividend is less than divisor, you stop the loop. Here it is dividend is less than divisor, but it's not the actual divisor, that is temp. So that's why temp equal to divisor you initialize, and we'll have a variable called multiply equal to 1. So next, as I said, until you have what dividend is less than, not less than, greater than temp left shift by 1. What we need to perform. Now we will see that. So this is outer loop, inner loop. So 20 and 3 you have. So dividend is 20. 3 left shift by 1 position means it will give you 6 into 2, right? So is 20 greater than 6? Yes, it is. So in this case, temp will be equal to temp. If this condition is again, then left shift by 1 position. And also multiply will be also be left shift by 1 position. So multiply will be equal to 2 now. and temp will be equal to 6. This is temp. Next again check. 20 you have. 6 left shift by 1 position will be 6 to the 12. Is 20 greater than 12? Yes, it is. Condition is true. So temp will be 12. So temp will move here now. And multiply will be left shift by 1 position. So 2 to the 4 it will happen. This is correct, no? 3 to the 6, 6 to the 12. So 2 plus 2 times 4 you got it. So next you again check. 20 you have. 12 to the how much? 24. So temp left shift by 1. So 24 you have. This time if you check, this condition will not be satisfied. So you stop here. You won't go inside the loop. So once you get this, so now outside the loop we'll have a variable called quotient that is initialized to 0. Now quotient plus equals to this multiply. So that means 4 will be added to the quotient. So 4 will be added to the quotient. And also after this, what we have to do, as I said, 20 minus 12 here. For the next step, 10 minus 6 you have to take. So 10 is nothing but dividend and 6 is nothing but temp. So dividend will be equal to dividend minus temp. So dividend equal to dividend minus temp you have to do. So I'll really go through this again. So 20 and 3 you have quotient 0 initially. Then why are we assigning temp equal to divisor? Because divisor should not change. For the next loop 20 minus 12 it will be 8 and then again divisor 3 is required. So you cannot change the original divisor. That's why you are initializing to temp. The multiply equal to 1 you have. Until you have the dividend greater than left shifting divisor by 1 position, temp by 1 position. Then if it condition becomes true, then left shift by 1 position. That means multiply the divisor by 2. Also multiply the multiple also by 2 because it's nothing but we are performing the multiply operation. So until you have this, once this becomes false, add multiple to the quotient, then dividend will be equal to dividend minus temp. So dividend minus temp is 8, then 3 you have quotient divisor. So is dividend greater than divisor now? Yes, 8 is greater than 3. So again temp will be equal to divisors, but temp will be 3 and multiple will be equal to 1 again. So it should be reinitialized to 1. So now we have to again check whether dividend is greater than temp left shift by 1 position. 3 2s are 6. So for 8 and 6, yes it is greater than 6. So temp will be equal to left shift by 1 position 6 and multiply will be left shift by 1 position. So it will be 2. Next again check for 8, temp left shift by 1 position 12. So this time condition becomes false. 8 is not greater than 12. So now multiply quotient will be plus equals to quotient was 4, 4 plus 2 that will be 6. So you got it. 20 by 3. The most possible division you can do is 3 6 are 18, then 19 20. So it is at about 6 point something. So the answer should be 6. We have got the 6. Since we are multiplying it by 2 to 2, even the quotient also multiplying, we have to multiply by 2 positions. So after this again check 8 minus 6 we have to do dividend. So that is nothing but we get 2. So in this case divisor is 3. So here only the condition becomes false because dividend is not greater than divisor. So it is false. And you stop the loop here. So this is how the code works. So at the last we have the quotient equal to 6 you have. Now what if 20 minus 3 we had? So that means sign was minus 1. So at last we are returning, we have to do sign, that is it would be either minus 1 or 1 into quotient. So that will solve the problem. So quickly we will program this. So this time we'll use C++. I'll explain the Java code as well. So first what we need to do, first step was what? We have to check whether the minimum and maximum value it is overflowing or not. So that case should be handled. So if dividend equal to int minimum and divisor equal to 1. So in such case return int minimum. What if it was reverse? If dividend equal to int minimum only and divisor equal to -1, then you have to return int max. So yeah, so after this second step comes in. So this is first step. Second step was this sign. So again calculate. So in sign is equal to if first you have to check whether dividend is less than 0 XOR with other thing is divisor that is less than 0. If any one of them becomes true in this, then what it will happen? -1 will be answer, otherwise 1 will be answer. So sign will be -1 if either of them is less than 0. If both are less than 0 or both are greater than 0, then answer will be 1. So next will be, you have to take long dividend, so equals to long absolute of dividend. Similarly for divisor also we have to take, so long divisor equals to long absolute of divisor. So yeah, here why are we taking long? I should explain, right? So see, we have 10 and 3, then 3 twos are 6 you do, then again 10, 6 twos are 12. So it at some point it will be greater than 10. Similarly, what if you had integer max value 2 power 31 minus 1, 2 power 31 minus 1, and divisor was 1 or 2, anything it may be. So if it is 1, then 2 power 31 minus 1, 2. So again 2 to the 4, 4 to the 8. Similarly, somewhere it will cross 2 power, it will be greater than 2 power 31 minus 1. So that will cause an overflow. So that's why we are taking long. So since this intermediate result causes an overflow, we are taking long here. I hope you guys have understood. So now next quotient will be equal to 0. So in Java it will be long only, math dot absolute will take. So next comes in while dividend. When here we have taken long dividend, right? So long dividend greater than long divisor, until long dividend greater than long divisor. First we need to take a variable called temp. So then that should be long. Yeah, long temp, because divisor is in long data type. So yeah, next int multiple, we will initialize it to 1. So next comes in while long dividend that is greater than temp left shift by 1 position. So if that becomes true, then temp will be left shift by 1 position, and multiple will also be left shift by 1 position. So this is nothing but, see, we have a equal to a plus b. So we will write it as a plus equals to b. Similarly, temp equal to temp left shift by 1 position means temp left shift equals to 1. Same thing we have written for multiple. So after this, what we need to do? Now we have to reinitialize the dividend, and before that quotient will calculate. So quotient plus will equals to multiple and long dividend. So that will minus equals to temp, because temp should be subtracted from that. So at last we have to return sign star quotient. If it is minus, it will be minus. If the sign is plus, quotient will be plus. So we'll run this. Yeah. So I'll quickly show off the Java code as well. So here we have integer.minimum value, integer.maximum value. So return accordingly, and sign also same case. As I said, math.absolute long we take. So next everything remains the same. We'll submit this also. Yeah, successfully submitted. If you understood the concept, please to like the video and subscribe to our channel. We'll come up with other video next session. Until then, keep learning.